Okay, so yesterday we discussed about Apache Kafka, and today we are interested in learning about Spark Streaming. And with Spark Streaming, we'll be doing one or two examples hands on. And after that, in the second half, we will be doing the integration of following components, that is Flume integrated with Apache Kafka. Then Kafka will go into Spark Streaming, and Spark Streaming will go into Hive. So all these things we'll be integrating. Kafka you have already studied. Spark Streaming you are studying today. Hive you have already studied, and Flume is part of the another module that we will be studying when we start another module. But I will give you basic idea of it. So this is the agenda for the day. Spark Streaming and one or two examples on that, and end-to-end application using Flume, Kafka, Spark Streaming, and Hive. Okay, so let's start with Spark Streaming. If you have any doubts, you can stop me in middle and ask me. Starting with Spark Streaming. So in case of big data, the data never stops. The data is continuously generated. Let's say in case of ATM, someone is withdrawing money each and every minute. Someone is using its credit card for shopping. Someone is using e-commerce website. Weblogs are getting generated as and when you are using websites and so on. So the data is never stopping. The data is continuously generated. Since this data never stops, we need some application in big data that can process this data, continuous data. So to process this continuous data, or to process this data streams, stream is nothing but a continuous data that is getting generated. So to process this data streams at real time, we have something called as a Spark streaming. So Spark streaming is nothing but it is going to process the data that is continuously generated, whether it be a weblog or whether it be a transactions that are happening on ATM or some other transactions happening on e-commerce platform or something else. It can also be from IoT, that is Internet of Things, which uses so many sensors. So all this data that is continuously generated will be processed by Spark streaming. So how Spark streaming works is, it works in micro batching. It works in micro batching. Let's say I define a micro batch of 2 minutes. So what it will do is, every 2 minutes it will process the data that is generated or received in last 2 minutes. So this will run every 2 minutes. Similarly, you can also configure it to run every 10 seconds. Or for real time application, you can also configure it to run on 2 seconds. It depends on your application. If your application is generating a hell lot of data, you will configure to very small period of time like 2 seconds and so on. But let's say the data being generated is small. Let's say you are considering a banking example of cash withdrawal or something like that in small country like Singapore, wherein it won't be so high. So for that case, your micro batch can be of 2 minutes. But let's say if it is some Facebook or Twitter that is doing, it can have a micro batch of 2 seconds or 1 seconds, or it can be even in milliseconds. So the processing of data that happens in Spark streaming happens in micro batching, and micro batching can be of 2 minutes or 10 seconds or 2 seconds. It depends on what application you are using it for. Now let's go back to what we studied so far. In case of Spark, when we studied Spark last time, we studied that in Spark the data is stored in something called as a RDD. Anyone, what is the full form of RDD? Anyone who remembers the full form of RDD?
Resilient dataset.
Yeah, distributed. Okay, resilient distributed. Okay, data set. So it is nothing but a non-immutable data set. That is, you cannot change the data in it once loaded. If you want to do something, you will put in another RDD. So resilient distributed data set is nothing but just like a variable where the data was stored, or just like a table where the data was stored. So in Spark, you had something called as a RDD. When we studied Spark SQL last to last week, if you remember, there was something called as a data frame. There was something called as a data frame. So we were loading the data into a data frame, and we were doing running the SQL query on top of it. And data frame was doing nothing but internally it was storing the data in RDD only. So it was internally RDD. So this is just a recap of what we did last time. And today that we are studying is called as a Spark streaming. Today we are doing is a Spark streaming. And in Spark streaming, you will be calling it as a D stream. You will be calling as a D stream. So D stream is full form is nothing but a discrete streaming. And again, D stream full form is discrete streaming, and D stream is nothing but internally RDD only. It is internally RDD. So it is just like D stream is nothing but a group of RDD. Let's say a 2 minutes of data cannot fit in one RDD. So let's say it is having 5 RDDs or 6 RDDs. All this RDD will form a D stream. This is all internally. You don't have to look into it, or it doesn't matter to you. But still, internally, everything is RDD. So when we started with Spark, we did operations on RDD. Then we did Spark SQL. It was a data frame, which was again a internally RDD. And today that we are studying Spark stream, it is called as a D stream, that is discrete stream. And it is again internally an RDD or group of RDD. So like if you want to perform some action on it, you want to do some arithmetic operation or any other operation or filter or something like that, you can either do it on a D stream, or you can also do on RDD. You can say that for each RDD you can do the operation. So it's up to you. You can do on D stream, or you can say for each RDD and so on. Okay, so uh, let's repeat. Let's have a quick recap of what we said till now. Data streaming, data Spark streaming, why we are using it? Because data never stops. Data is generated continuously, be it by ATMs, or be it by credit card transactions, or be it by the data streams that be it IoT sensors and so on. So to process this data stream at real time, what we use a Spark streaming. And going further in doing, when we are programming for Spark streaming, we will process the data in micro batch. The micro batch can be of any duration. It can be 2 minutes, it can be 10 minutes, it can be 10 seconds, it can be 2 seconds, it can be milliseconds, and so on. So whenever let's say I am doing for 2 seconds, so every 2 seconds it will process the data. Then next thing we saw that it is like Spark, we were using RDD, resilient distributed data set. For Spark SQL, we were using data frame. Data frame was nothing but internally an RDD. And again, Spark streaming is nothing but D stream, and internally it is again a RDD. Okay, anyone having any doubts in so far? If you have any doubts, you can stop me in middle. Going forward, going forward, Spark can be used with Mesos as well. It can be used standalone as well, or it can be used with Yarn as a resource manager. So Mesos is rare, not used much, and Yarn is the thing that is Spark is used with. Yet another resource negotiator that we have already studied when we were doing basics. So let's say uh, the driver, like we studied in the first class of Spark, if you remember, there was something called as a driver, and there was something called as a Spark context. If you remember the first class of Spark, there was something called as a driver and there was something called as a Spark context. Now this driver, if you remember last time, we studied that driver does not have any business logic, does not have a business logic. It is not having any business logic, and it only controls the flow. So let's say when you are submitting this Spark streaming context or Spark streaming, let's say you are submitting a Spark streaming job, and let's say your driver fails. Driver is the one that is controlling the entire flow. So let's say if your driver fails, then in that case, the Mesos or Yarn, they will restart the driver. Restart the driver. So like Mesos is having some flag that is called as a supervised flag. Similarly, Yarn is also having some setting. What that does is if the driver fails, it restarts the driver. And driver was basically calling the Spark context. Similarly, when you did SQL, it was something called as a Spark SQL context. And when you will be doing Spark streaming, it is called as a Spark streaming context. So the driver is the one that will control the entire flow. And this thing Spark context, Spark SQL context, and Spark streaming context we'll be using when we do all the programmings, when we do programming today. Anyone, any doubts so far?
Harish, can you repeat to this Mesos? Because Yarn is the resource management, right? Which is responsible for the resource. What is the purpose of this Mesos?
Uh, Again, if you can recap if you can remember the first class of Spark again, when we studied how this Spark actually started. Actually, in the year 2009, before year 2009, I'm just going with the history, nothing related to this. There was Hadoop 1.x, if you remember. So Hadoop 1.x was having two components. It was having two components. There was a file system, that is HDFS, and there was a map reduce, if you remember Hadoop 1.x. So there was no separate resource manager. Of course, when Hadoop 2.x came, there was a resource manager, HDFS, and there was a map reduce over here, and there was a resource manager Yarn. So this was the story about Hadoop 1.x and 2.x. Before Hadoop 2.x actually came, in the year 2009, there comes Mesos. So Mesos was nothing but a resource manager, just like Yarn. Yesos was also a resource manager. So it was developed in some university in US. I don't remember the university name. So Mesos was again a resource manager that was developed in year 2009 approx, and for managing the resource. So what they did was they started testing Mesos. Is it working fine or not? They tested it with MapReduce and it was working fine. And Mesos was working excellent. And they also, to test this Mesos, they actually developed something called as a Spark to test this Mesos. So with Spark, they were testing Mesos and Mesos was working fine. But bad luck for Mesos, Mesos did not go well. It was not adopted by industry much. And Yarn comes and Yarn is again super hit and everyone is using Yarn. So Mesos was again a resource manager, but its faith was not good, not used at much places. And then the developer realized that, oh, though the Mesos failed, Spark is a good thing. So they rebuilt the Spark and came out with Spark in 2014. And so we use Spark, but Spark was not actual product. Actual product was Mesos, and Spark was just a byproduct that was built to test the Mesos. Okay, so this is the history of Mesos and Spark. And basically, to answer your question, Mesos was another resource manager, but that never worked. That was a failure. Okay, it was not that it was not good or something like that, but it was not adopted by companies. Okay, anyone, any other doubts? Anyone? Anyone, any doubts? Or else we can go ahead. Okay, if no doubts, then we'll go ahead. And if you want to practice with me, you can also bring up the virtual machine. So if you want to practice with me, you bring up the virtual machine and download these stuffs. I will show you the things that you need to download. So you need to go into this place, Google Drive. In Google Drive, go into Spark and go into Spark Streaming, go into class material. And these are the three examples that we'll be doing. First and second example is related to Spark Streaming. And third example is the end-to-end application. So this is the first example. EMP1, EMP2 is my data set. It is having some data. Let's see this data. So we are starting with first example. Go inside Spark Streaming, class material, first example. And this is my instructions that we'll be doing one by one. Let's look at the data, how it looks. So this is my data. Basically, it is a comma separated. So one, Harish one, 10,002. It should be enter something like this. So this is my data. So it is one Harish one 10,000, two Harish two 20,000, three Harish three 30,000. So this is my dummy data that is separated by commas. This is my first file, and let's see second file as well. So this is my second file. It is having one Harish one 10,001, two Harish two 20,002, four Harish four 40,004, five Harish five 50,005, and six Harish six and 60,006. It is a comma separated data, and basically I will be moving this data, streaming this data from one part to another part to show how the data is traveling. Let's do this in virtual machine. If you want to practice with me, bring up your virtual machine and we can do together. Instructions are there in Google Drive. You can download it and we can do it together. If you prefer to do it later, you can also do it later. Okay, so my virtual machine is almost up. Okay, it is almost up. And let's start with it. How do we this is my practical folder that you can find it from the Google Drive, and this is my first example that we are going to do. And this first example, employee 1 and employee 2, you have already seen how the data looks like. 1 Harish 1, 10,000, 20,000, 30,000. So this is my data basically in both of these files. And these are the instructions that we will be executing one by one. So let me keep the instructions on one side and let's practice it in another side. Okay. So all the steps are written over here. Prerequisite, create a directory, home Cloudera streaming. So what I will do is I will create a directory in HDFS at this path, home Cloudera streaming. So let me start my Mozilla browser. Then after starting the Mozilla browser, I will go inside Hui. Okay, we are inside Hui. Then we can go inside file browser where we can see HDFS files. If you are doing with me, do let me know if you want me to stop. So I'm going inside file browser. Then I am already inside user Cloudera and I need to create a directory by name streaming. I already have one directory, so first I delete it. And I create a new directory. To create the new directory over here, just click on new and click on directory. And the name of the directory should be streaming. So I'm creating a new directory streaming. So this was my first prerequisite, that is to create the directory at this location, user Cloudera streaming. Okay. Then I need to start the Spark shell. To start Spark shell, it is command is Spark shell. So I will write Spark shell. So Spark shell will do nothing but start the Spark for Scala, the shell prompt for Scala. Similarly, you can also start for Python by writing PySpark. For Python, it is PySpark. For R, it is Spark R. Spark R, you need to install it first. And similarly, if you are doing with Java, you don't have any command line interface. So no CLI for Java. For Java, you have to write the entire program directly. So, but we are working on Scala, so it is Spark shell. Python is PySpark. We are not working on Python. R, we are not working. R is used for mathematical purposes. Spark R, for Java, there is no command line interface. So we are starting the command line interface for Spark with Scala. Okay, so you can see that it is already started and you can see Scala is written over here. By default, it will give you all the messages like info, warning, as well as error. Like this is showing info, all this showing, it is showing info. This is my warning. There is no error. because else it won't have been started. So this is all info, this is warning. So let's say I don't want this info to full my screen, so let's make the log level to warning. So if I set this log level to warning, it will only show warning and error, it won't show info anymore. It will only show warning and error. Then going to third step is to import. Third step is to import org.apache.spark streaming. So for Spark streaming, you need to import it. Then I am configuring the Spark streaming context, and I am passing SC, that is Spark context, and I am saying that seconds are 5. So I am specifying as 5 seconds. Depending on your application, it can be 5 seconds, 60 seconds, or whatever. So I am configuring it so that it will the streaming application, or it will be doing in a micro batches of 5 seconds. Then I am defining the structure of the data. The data that I have made for the employee file, the file that we just saw, it was having ID, that was 1, 2, 3, 4, 5. Then it was having the name, that is it was having Harish 1, Harish 2, Harish 3, and it was having the salary 10,000, 20,000, 30,000, and so on. So I am defining the structure of the data so that I can use that data. So I have defined the structure of that data over here. If you have any doubts, you stop me in middle and ask me. Then after this, I am defining the path. The path is user Cloudera streaming. It is nothing but this path, the path from which I want the data. So user Cloudera streaming. So I'm defining this path over here. ssc.text file stream. My text file stream is coming from user Cloudera streaming. So my data is coming from this path, and it is coming into this RDD. The RDD name is EMPD stream. So this, whatever this data is coming, it is coming in this D stream. This is nothing but a discrete stream, but internally it is made of RDDs only. So my streaming data, whatever is the streaming data, will come inside this EMPD stream. And then what I do is, let's look over here. It's EMPD stream where I got the data. It's EMPD stream where I got the data. Then I say for each RDD, I am using the map function and I am splitting the data by comma. First thing that I do is I split the data by comma. First thing I do is I split the data by comma. Why I'm splitting by data by comma is because my data is having comma in between. You can see over here. So my data is having comma in between. That's the reason we are splitting the data by comma. So line dot split by comma. Then I map each line into, first one is the integer. So we are converting it into integer. The second one, because I zoomed in, it is not showing properly. Let me zoom out again. Okay. Let me press enter. Okay. I will show from here because everything is not visible over here because I zoomed in and zoomed out. Let me see. Okay. Now it is visible. So I was explaining this to you. First I said that we split by comma. Then we break this into, first was the integer, that is my number. 1, 2, 3, 4, 5, 6. Second was the name, that is Harish 1, Harish 2, Harish 3, and so on. And third one was my salary in double. It was a floating point. It can be a floating point. It was 10,000, 20,000, 30,000, 40,000. And I am just printing it. So just look into this instruction again. First thing I am doing is I am splitting by comma. Second thing, I am mapping into three fields. First field is the sequence number. Second field is the name, and third field is the salary. And then I am printing onto the screen. Okay, then I am printing into screen. Let's go into next instruction. And next one is ssc.start. That is, I am starting the Spark streaming. ssc.start. Okay, so ssc.start is started. The streaming has started. So whatever data that comes into, whatever data this EMP1 and EMP2, whatever data that comes over here should appear to me in this streaming context. Let's put one data. Let's put this EMP1 first. So what I'm doing is I'm dragging this EMP1 and I'm dragging it into user Cloudera streaming. As I put the data over here, as the data comes over here, you can see that data has come over here, and every 5 seconds the job will run. So this data came, every 5 seconds it will automatically run, and whatever was the data that came over here is coming over here, and it is formatted, it is converted into double. This is my serial number, this is my name, and this is my salary. Let's say I put one more file. Let's say I put EMP2 file again over here. So I have put one more file over here. So this should also come in 5 seconds. So it is again 1, 2, 3, 4, 5, 6. The second one was having one salary was bit different. Instead of 10,000, it was 10,001, 20,002, 30,003, 40,004, 50,005, 60,006, and so on. Similarly, if I want to stop it, I can do ssc.stop. I can do ssc.stop. ssc.stop. So if I want to stop this, the command is ssc.stop. So this is the simple example of Spark streaming. What did we do starting from? First thing that we did was we created a directory. Then we started the Spark shell. Then we set the log level to warning. You can set it to warning or error. Even if you don't do, it's still okay. In that case, it will also give you all the informations and so on. Then I imported the Spark streaming. After importing, then I said that I want this to be processed every 5 seconds. Then I defined the structure, how the data is present in that file, whatever will be coming over there. Then I defined the path. What is the path? User Cloudera streaming. And I was taking the data from this path into this D stream. So this is my D stream in which my data is coming, and D stream is nothing but internally group of RDDs. And then what we did was, for each RDD, first we separated the data by comma, then we mapped into these things, and then we printed it on the terminal, and finally we started. Then what we did was we just dragged and put this EMP1 and EMP2 in this path, and these all things started appearing on my command line interface or my terminal. To stop it, it is ssc.stop. Anyone having any doubts in this? Anyone, any doubts so far?
Harish, what is the triggering point of this batch? Like every 5 seconds, it is going to recheck what? Like, is there any update in the file or is there a new file uploaded? So how we have defined it? What is the triggering point?
Okay, update of file is not supported. Update of file
No,
is
no.
not supported. Like it is the
Okay.
triggering point is some data should come over here. If I update something inside this, it will not be supported. It won't appear over there.
Okay. Okay.
But
So it's only.
only like it is used for a weblog kind of application that I have seen practically. And let's say once the
Mm-hmm.
weblog is generated in my Linux server where my website is hosted, so that log they will be pushing into one directory, and
Okay. Got
as
it.
the data comes in that particular directory, it will be fetched into Hadoop cluster,
Okay. Got it.
and it will be using Flume and Kafka and so on. This one is simple example that we are taking from HDFS only. The last example will be end-to-end application.
So you told yesterday, like, for example, there is a Twitter. We keep on updating the blogs in Twitter, or writing something on Twitter. So we can also do that kind of thing, right? In this Spark system.
Yes, we can also, what we can do is for Twitter, we can configure it. Let's say we can put Flume on the Twitter side. Then Flume can also directly get the data inside Hadoop as well. Or else we can use with Flume, with Kafka, with Spark Streaming. We'll see the last example.
Okay. Okay.
After that, it will be more clear how the end-to-end application works.
Okay.
Okay.
Hello, Harish.
Yes, sir.
Can we write the same output into another file? Can we do it now?
Yes, we can write the same output in another file. You mean to say, can I put the data in some other directory or something like that? Process and
Yeah.
write into some other file?
Yes.
Yes. In fact, we will be doing in the last example.
Okay.
Yeah, we'll be doing after break today only.
Okay. And can we do it as same similar example instead of fetching from a file? Can we do it from a table?
Yes, we can do it with fetching from the table also. You can integrate Scoop with it.
No,
So,
without integrating in scope.
no,
Directly connecting to MySQL through
no,
JDBC connection.
no. It needs some custom application like Scoop is there. Then there is one more application. There are many such tools like Talent is one of the company that is an open source company, and they also have some tool for fetching the data that is written in Spark that also can do, but cannot do directly with Spark streaming. You need some tool like Scoop or something else.
Okay. Talent is open source for limited edition, right?
Uh,
But Spark is not supported in open source. That is in enterprise edition.
Spark is in enterprise. Hortonworks has a Spark in open source as well.
Yeah,
Hortonworks
yeah, but
Hortonworks do give in open source. Hortonworks works on open source module view of business only.
no, I'm saying about Talent.
Okay, yeah, Talent, yes. Talent, it's in enterprise, yeah. Talent will be charging.
Okay.
Okay. So anyone, any other doubts? Okay, so if no doubts, then we'll go to second example. This was my first example. Let's go into second example. Okay, second example, instructions are over here. You have to go inside second example. And these are my instructions. And like if you remember, the first example that you always study in Hadoop was a word count. That is, if there is a book, there are how many times a word is coming. Similarly, word count example, similar to the same word count example that we have done so many times as a MapReduce program, or be it with Hive or be it with Pig. Similarly, we will be doing same word count program now, but the difference will be the data is generated continuously. So every 5 seconds, let's say the data is generated, and we will analyze the data that is generated every 5 seconds to do the word count. So this is again a word count example. We are starting with a word count example. The difference over here is the data is continuously generated as compared to the word count example that we do previously. In the previous examples, the data was static. The data was from some ebook or something like that. Now the data is generated continuously. So we'll start with word count example. All the instructions are present over here, and you can just follow this. So I need 2 sessions. I need 2 terminals. So I have started 2 terminals, and the instructions are present on my left side. The first thing I need to do is the data will be the word count that I want to do. I will write that word count over here. Whatever words I want to give, I will write over here. Like I will say ABC, ABC, SC, ABC, whatever, SD, something like this. And it will count and say that ABC is coming 3 times, SC is coming 1 time, and SD is coming 1 time. So I'm having 2 sessions. First session I will give the streaming data, and second session will analyze that data. So let's say the data that I'm giving is from the port number 4444. You can put any port numbers. So NC is for netcat, and I'm just starting this port 4444 in this session. And this session will listen to this port 4444, and it will do the analysis, it will do the word count. So this is my first port wherein the port number 4444 is started, and this is my second session wherein the actual analysis or the code will be written. So first thing that I need to do is I need to start the Spark by writing Spark shell. So we are starting Spark by writing Spark shell. So Spark shell is starting. Okay, so Spark shell is started in Scala. Then we set the warning level to warning. So sc.setLog level to warn, that is, it will only show me if there is some warning message or error message. It won't be showing me info messages. Then I need to import the Spark streaming. So I'm just importing it. Then I say that I want to do it every 2 seconds. I want to do this. I want this to run every 2 seconds. So I am just specifying it to be 2 seconds. You can specify any other different value. Then I am defining my discrete stream, and what I'm saying is my streaming Spark streaming context dot socket text stream, and it is coming from the local host because it is the same IP address. It is coming from the port number 4444, and the storage level is memory only. That is whatever is the data, it won't be stored anywhere, it will be in RAM. So I am specifying basically from where the streaming data will be coming. So it will be coming from this port 4444 that I need to specify over here. If port 4444 is not working for you, you can change it to some other port, and make sure that in both of these sessions you use the correct port number. Okay, going further. So this D stream, I'm saying that val word count, which will be another D stream, and I'm saying that the data that is received over here, split it by spaces, because I will be giving the value as spaces over here. Let's say AAA space AAA, something like this, BCD AAA BCD DEF, something like this. So I'm giving it by spaces. So I'm splitting it by spaces first. Then I am assigning the value 1 to each and every word. I am assigning the value 1 to each and every word. That is, this word AAA will have the value 1. AAA will have the value 1. AAA will again have the value 1. BCD and BCD will again have value 1, 1. Everyone will have value 1. And finally, it will reduce by key. So that means it will bring all AAA will together and it will do 1 plus 1 plus 1, that is 3. BCD and BCD together and do 1 plus 1, that is 2. DEF will be 1. So basically I am splitting by spaces first, then assigning the value 1 to each and every word, and then I am doing a reduce by key. Okay, so this is done. Then whatever is the output, I want it to be printed over here. So whatever is the output of above will be printed over here. And then I need to do start, ssc dot start. So I have started over here. So I can write anything over here. So whatever value I have written over here, it will come over here. Like over here, Harish was 3 times. So Harish was 3 times. In this line, if you see BCD, DEF, BCD was 1 time, A was 2 times, and so on. And whatever is this is how many times it is, you can see over here. So BCD was 2 times, A was 3 times in the first line, and so on. One more thing that you can notice over here is it is happening every 2 seconds. So you can see that it is 88,000 milliseconds, 90,000 milliseconds. So it is like 90, 92, 94, 96. So the time is in milliseconds. 98. So you can see the difference of 2 over here, because I said that 2 seconds. So it is basically 2000 milliseconds difference if you see over here. So this is basically running every 2 seconds, and whatever data that I have passed over here will be coming over here. So this is how you can do a simple example of word count. It is same as the word count example that we have studied so far in Spark, Scala, uh, Python, MapReduce. Then we also studied this in Hive, we studied this in Pig, and so on. We studied everywhere. So it is the same thing that we are doing in Spark streaming, and we are getting the word count. Let us repeat what we did till now. We started the first session and we said that netcat to 4444. So this is my port number 4444 that is started over here, and basically I'm passing this data from here. Then I started the Spark shell in this session. Then after starting the Spark shell, I said that I only want the warning messages, I don't want info messages. Then imported the streaming context, and then I said that I want to run this every 2 seconds. then we give from where the data is coming, then we split it by spaces, assign the value 1 to everyone and reduce by key, then we printed it, and finally we started it, and whatever data that we wrote over here, every 2 seconds it is processed. Whatever data is written over here, every 2 seconds it is going to process, and I will get the result over here. So anyone, any doubts in this? The program logic is same as we did the word count in Spark with Scala. The program logic is exactly the same. Anyone, any doubts?
Harish,
Yeah.
can you repeat for one more time? Probably I need to recall. Reduce by key. We are assigning one to every word, right?
Yes.
We are splitting it by space. We are assigning one to every word, and then reduce by key. What exactly
Okay.
it is? I'm
Okay.
not able to recall.
Okay. Let me take this example. Let's say Harish, then A, B, C, D, and Harish. So let us see by this example. I'm not explaining now because it is the same thing, but let's anyhow explain. Let's do it again. So first thing that we are doing is we are splitting by spaces. So when I do split by spaces, it will become Harish, Harish, A, B, C, D, and Harish. So split by spaces will separate it by spaces everything. Then second thing, when I say assign the value 1 to everyone, so what it will do is it will assign the value 1 to everyone. Okay. So second thing that it did was it assigned the value 1 to everyone. Then this is my key value pair. This Harish is a key and 1 is a value. Harish is a key, 1 is a value. Harish is key, 1 is value. AAA is key, this 1 is value. BCD is key, 1 is value. Again, this Harish is a key and 1 is value. And then when I say reduce by key, it will bring all the keys together. So my keys over here is this Harish, again Harish, and Harish 4 times. So it will bring all Harish together and the value will be 4 to it. 1, 2, 3, 4. Again AAA will come together and it will be value 1 for it. BCD is again only one time and the value will be 1 for it. So reduce by key will bring all the keys together and its value, it will add its value. So it will bring all the Harish together, 4 Harish together, and it will add all its value. 1, 1, 1, 1 will become 4. Okay. So is it clear?
So this is reduced by key. We are passing on plus. So that means it is adding those values, right? Whatever the values we are having for those keys.
Yes, it is a short notation for adding. Yes.
Okay. 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 And
Yes.
Harish, other than this, this is something we are, updating the data. So again, the same thing. Like if we need to connect it to some live data,
Mm-hmm.
like Facebook
Okay.
post or Twitter.
Mm-hmm.
So we are going to cover that later, right?
Yes, yes, yes. We'll be covering that.
Okay.
Okay. Anyone, any other doubt? Anyone, any doubts in this? Okay, so if no doubts, then we will. The time is 11 o'clock at my place. Let's take a break of 10 minutes. Whatever is your geography. So, my place it's 11 p.m. Let's come back at 11:10 p.m. If you're in US, it's AM. If you are in India, then it's approx 8:30 if I'm not mistaken. 8:40 p.m. Just take a break of 10 minutes. If you are in US, it is either 11 or 10. Depends again which geography you're connected. So let's take a break of 10 minutes and after that, after coming back, we will be doing Flume plus Kafka is equal to Fluffka. Okay, Flume plus Kafka is called as a Fluffka. It is a short form. Like Saif Ali Khan and Karina is Saifina. Similarly, you also call it Flume plus Kafka as Fluffka, and we will integrate it with Spark Streaming, and we'll be integrating with Hive. So this is the final example that we'll be doing. It will take some time. So let's take a break of 10 minutes, come back at 11:10 or 10:10 or 8:40, or accordingly. You take a break of 10 minutes and come after 10 minutes, and we'll do this example. Thank you.